Hello everyone, welcome to Legacy IAS. Today we'll be dealing with another topic, that is electromagnetic spectrum. Now, this is electromagnetic spectrum. Now, before you understand this, you might have heard about waves and all, like ultraviolet waves, visible light, okay, X-rays, all these. So whatever is their arrangement, that is called electromagnetic spectrum. We'll get to it. First, let's just understand what is a wave and few small components of wave. Okay, so wave, like when you travel from one point and you reach back to the same point with respect to axis, that is called one cycle. Now, this length on the axis that you have when you cover one cycle, this is called wavelength. This you might have heard, wavelength, a very normal term. So this length that you are seeing is wavelength. Then understand this. So this length you look at, the height that the maximum height that it reaches from the midline or from the axis, this is called amplitude. Fine. Then another term is the time taken to complete one cycle. Time taken to complete one cycle is called time period. So if a particle has to travel from here to here, the time it takes, that is called time period to cover one cycle. Then last term is frequency. Okay, now frequency, you might have heard it a lot. Frequency बढ़ा दी, हमारी frequency match होती है. All these words you might have heard of. So frequency, what is frequency? So understand, if I draw wave like this. Now let's say in 1 second it travels, a particle travels from here to here in 1 second. Then in this 1 second, how many cycle has this particle completed? How many cycles? So you see here, this is one cycle, this is first cycle, this is second cycle, and this is third cycle. Correct? So 3 cycles it can complete in 1 second. Then you say what? You say frequency is number of cycles per second. So here frequency will be equal to what? 3. Understood? So frequency is number of cycles per second. These are the main things that you need to know about a simple wave. Now we'll get to electromagnetic spectrum, how it works and all the things. Now one thing before we move forward is you can feel the relation between frequency and wavelength. How? See. Now you might have heard that he speaks at a very high frequency, like that. You might have heard people saying, okay. Now you must have seen when you are playing songs, it gives you a diagram like this. Have you seen this? Correct. Now if somebody is singing or speaking very slowly, the diagram looks smaller. Okay, and if somebody is speaking very fast, then it becomes very close and like this. Okay, so this is because of change of frequency and wavelength. Now understand, if something is going like this, okay, versus something that is going like this. Now, which of these two do you think will have more frequency? Now clearly you can see, let's say I draw a diagram for 1 second only. So clearly you can see how many cycles are getting completed here in 1 second. 1, 2, 3, 4, even more than 4. Here only 1 and 2. Correct? So you can feel it that when a wave looks like this, when a wave looks like this, it has more frequency. This is correct. This has more frequency. But on the other hand, if you look, what is the wavelength here? When I'm reaching the same point, so from here to I reach here. Now, what is this length? This is the wavelength. Now, this wavelength is bigger, or if I go from here to here, this wavelength is bigger. Which do you think is bigger? Very clearly, wavelength is bigger here. So that means which has more frequency? That wave, but it has lower wavelength. It has higher frequency but lower wavelength. And that is the first fundamental relation that you know of. That is frequency and wavelength go in opposite direction. Now, one more relation that you need to understand is, if something has more energy, then also it will have more frequency. That's why if I speak very loudly, my wave looks like this. So frequency and energy. Frequency and energy go hand in hand. So energy and frequency are directly proportional, and frequency is inversely proportional to wavelength. Energy is also inversely proportional to wavelength. Correct? Now let's get to the electromagnetic spectrum. Let's see this. Now you can see it clearly here also. As you can see here, wavelength is more, and slowly what it is becoming? Wavelength is becoming smaller and smaller. Here the wavelength is just from here to here, very small wavelength, and if you see from here to here, wavelength is much bigger. So clearly wavelength is decreasing towards this side, and what is increasing? Number of cycles per second is increasing. So basically frequency is increasing on this side, and wavelength increases on this side. Also, you know something intuitively, that some waves that are on this side will have more energy. How do you feel this? See, you understood the relation frequency and wavelength, so you also understand energy and frequency goes hand in hand. So you understand that this is also the direction of increase of energy. Frequency is also increasing on this side, energy is also increasing in this side, wavelength increases in opposite direction. This you understand. Now how do you feel it intuitively? Okay. You may have seen uses of all these lights. For example, radio waves. Correct? Radio waves, you hear radio channels on your phone, everything, most of it is radio waves, the Wi-Fi that you are using. Now, is radio wave anyway interacting with you? Nothing. You don't feel anything. It is, of course, not causing anything in you. Now, you go to next, that is microwave, and then infrared waves. Now, infrared waves, if you might have known, the energy that they have is much smaller. That is why if somebody is like using a remote, in remotes we use infrared rays, and you stand in front of it, it gets completely stopped. You cannot use the TV behind me. Correct? Then you come to visible light, which has more energy, clearly more energy. Then after this you get to ultraviolet. Now ultraviolet, if you can feel, ultraviolet can get to at least 2 layers of your skin. Correct? That is how it causes sunburns, and you understand this. So basically it can go till 2 layers of your skin. After this you have something called X-rays. Now X-rays have more energy, they are more powerful. That's why they can get through your whole layer of whatever skin you have, as well as the fat that you have. Now fat, many people may have different, I may have more, you may have less, but everybody has fat. So crossing all those layers, eventually you get to X-rays that can even go till your bones, but it cannot penetrate your bones. Correct? That is why in cancer therapy you use something called gamma rays that can go even beyond bones. So this is gamma rays. Now you see the uses, you will understand everything. So first is this radio waves. This is used to broadcast. This is used to broadcast radio and television. Then you come to microwaves used in cooking, radars, telephone, other signals. Then you come to infrared. Infrared is mainly used for transmission of heat. For example, when you see fire burning, so yellow color that you are seeing in fire, that only is visible light. But that is not providing the heat. Heat is mainly provided by the infrared rays. Correct? Sun also sends incoming higher infrared rays to heat. So this is infrared rays. Next is visible light. Of course, visible light is useful. It is making you see this video, correct? Then next is ultraviolet. This is absorbed by the skin and this is used in fluorescent tubes. Now next is X-ray to view the inside of bodies and objects. Clear? And last is gamma rays, that is used in medicine for killing cancer cells because it has to go through even bones and get to the internal organs. For example, heart, for example, lungs. Correct? So all that it has to go. So this is what you understand now. Now see, same thing is given here also. As you can see, the frequency is in this direction. Frequency is constantly increasing, and what is decreasing? Wavelength is decreasing. Correct? Now, one thing that you must remember is about this visible light. That which part of visible light lies where. So understand what you have here is infrared. So just after it, what you will have? You will have red. What you have here after visible light is something called ultraviolet. So what you will have at the last here? You will have here. At last you will have here violet. Because this is next is ultraviolet. So that is how you remember the range of colors in visible light. So it will look like VIBGYOR. That's it. Starting from red, and in this direction what increases? Energy is increasing on this side. This side energy is increasing and wavelength will be increasing in opposite side. Then some examples is given, okay, where you can find them. Correct? So all these is for you to understand electromagnetic spectrum. This is the spectrum, that is the entire varied waves that are present. Okay, now there are two formulas. You may not know them, but just it is good to understand them once. So one formula that we have is E is equals to HF. H is a constant and F is actually frequency. So you understand, energy is directly proportional to frequency. One more formula you have is equals to E is equals to hc by lambda. H is again a constant. C is actually speed of light. Speed of light. So this is also constant. What you get? Energy is inversely proportional to wavelength. Here you get energy is directly proportional to frequency. You join them both. Frequency is inversely proportional to lambda. This is what you will find in books. I've also taught you intuitively how you would feel this or get this. Okay, this you can remember. This is the relation, and this you need not remember that much. You anyway understand what is the penetration level. X-ray, gamma rays, they have to go inside. So we'll have more energy, more frequency, less of wavelength. That's it. Simple. And then you can backtrack all of them else. Okay, that is it for electromagnetic spectrum. Thank you.